Assalamu alaikum. Well, children, we were doing exercise number 1 of the trigonometry chapter, and we have so far completed question number 9. Question number 9 we did last time. 2 more questions from first exercise are left here. Just to remind, the exercise is based purely on the definition. We'll use the definitions of those trigonometric ratios to solve question number 10 and 11 also before we move to the next part of this chapter. Here we have question number 10. According to the statement, we now have a triangle PQR right angled at Q. Let us draw the diagram to understand the question. A right triangle is there, right angled at Q as per the statement. Name of the triangle is PQR. P and R you have to write on your own choice. Q should be the vertex containing the right angle as per the statement. So this is the triangle, right angle at Q. P is the acute angle, R is the acute angle. Now, unlike the previous questions, this time we are given the sum of two sides. Sum of two sides of the triangle is given. PR plus QR, 25 centimeter. In triangle PQR, what do we have? PR plus QR is given. Sum of the two sides. PR is the hypotenuse. QR is one of the sides, remaining sides. The sum is given to be 25 centimeter. And another thing is given, PQ, the third side, is separately given. PQ is equal to 5 centimeter. This is the information given to us. Only one side is separately given. The sum of the remaining two sides is also given. If you recollect, in solving previous questions, before getting the results as per the statement that were asked, we had to find the lengths of all the three sides, individual sides. Here only one side is directly given. The remaining two sides have sum equal to 25 centimeter. So our first effort will be to find the measures of these PR and QR, which have sum equal to 25 centimeter. Now, after finding those individual sides, PR and QR, we will find, as per the statement, we are asked to determine the values of sine P, cos P, and tan P. We have to use P as acute angle here. Sine P, P is the acute angle. Cos P, P is the acute angle. Tan P, P is the acute angle. So we'll decide with respect to this P first, which side we'll call as base and perpendicular. Hypotenuse, of course, does not depend on the acute angle. It is the side opposite to the right angle. You can identify Q is the vertex containing the right angle. Opposite side is PR. This will be therefore hypotenuse. And then out of the remaining sides, PQ and QR, which one you will call as base, which one you will call perpendicular, the adjacent side of the acute angle that is involved, or that is chosen, is called the base. So that is PQ here. This is the base of the right triangle. This will be the perpendicular. Now use this information to find the remaining two sides. There are a number of ways of doing this. One of the ways is application of Pythagoras theorem. According to Pythagoras theorem, we'll have PR square equal to PQ square plus QR square. Right? We know PR square, this is the hypotenuse, square of hypotenuse is equal to sum of the squares of the other two sides. PQ square plus QR square. This is Pythagoras theorem. Then out of the three sides, you know the measurement of PQ. 5 centimeter. Let's substitute that. So this will become PR square is equal to 5 square. For PQ, we'll write 5 plus QR square. Square of 5 will become 25. So it will become PR square is equal to 25 plus QR square. Is this clear? Now next, we'll transpose this QR square to the left side. Being positive, it will become negative. We'll therefore have PR square minus QR square is equal to 25. We transpose it QR square. Our aim is to find the measurement of PR side, the hypotenuse, and QR side, the perpendicular. PQ is given to us, which is the base, 5 centimeter. Remaining 2 we want to find, and this is the procedure we have used. Pythagoras theorem I have applied. Then I substituted the value of PQ, transposed QR square. Here you can use the algebraic identity, A square minus B square. That is A plus B into A minus B. So it will be then PR plus QR multiplied by PR minus QR. Algebraic identity, A square minus B square equal to A plus B into A minus B I have used is equal to 25. PR is A for us, QR is B for us. So it is A plus B, PR plus QR, A minus B, PR minus QR. Out of these, the value of PR plus QR is given to us. We'll substitute that. PR plus QR is given to be 25. Let us use that here. So it will be then 25 multiplied by PR minus QR is equal to 25. Transpose 25, PR minus QR, then will be 25 divided by 25, which means 1. So we have PR minus QR equal to 1. We already know PR plus QR. Just now we used, it is given to us PR plus QR is equal to 25. So we have two results therefore. Involving the variables PR and QR. This therefore forms a pair of linear equations in two variables. We have already done the chapter based on that pair of linear equations in two variables. PR and QR are the two variables in the first equation here. PR and QR are the two variables in the second equation also here. Solving pair of linear equations in two variables, you have read earlier. Three different algebraic ways of finding PR, of solving a pair of linear equations in two variables you have done. Substitution method you have read. Cross multiplication method you have read. And elimination method you have read. One of those methods you have to use. I shall here opt the method of adding the two, because we already have their coefficient same. QR has got different sign. It is negative here, this is positive here. So therefore elimination will be done by adding these. So let us add them by adding. We add left hand side to left hand side, right hand side to right hand side. PR minus QR is the left hand side of the first equation out of the two, plus PR plus QR, left hand side of the second equation of the two, is equal to add their right hand sides, 1 plus 25. Now on the left hand side, QR and QR will cancel. One being negative, another is positive. These will cancel. What will be left? Twice PR is equal to 26. You will get PR, therefore 26 divided by 2 means 13 centimeter. Unit used is centimeter here, 13 centimeter. Thus we got measurement of PR also. Already PQ is given to us. Now what is left is QR. That value of QR will again get from this expression. We are given PR plus QR is equal to 25. Right, again. PR plus QR is 25. given to us. Now in this, use the value of PR. Just now we found 13 plus QR we would like to find is equal to 25. Transpose 13 to get the measurement of QR. 25 minus 13, 12 centimeter. Thus we got the lengths of all the three sides. PQ was given, sum of PR and QR also was given. We used that result to find individual measures, PR and QR. We got PR equal to 13 centimeter, QR equal to 12 centimeter. Now, knowing the lengths of all the three sides, let us find the required result. Sine P we have to find first. Right now, sine P is equal to, recollect the definition of sine. Some people have, sine is perpendicular by hypotenuse. You have already identified perpendicular and hypotenuse with respect to the acute angle P. With respect to acute angle P, QR is the perpendicular. So it is QR here. Divided by hypotenuse. PR is the hypotenuse. Use their values. QR is 12. Divided by PR is 13. Therefore, sine P becomes 12 by 13. Similarly, you have to find cos and tan. You can now find those. Cos P by definition is base by hypotenuse. Again, this definition we get from that second part of that statement. Curly black here, cos is base by hypotenuse. With respect to P acute angle, PQ is the base. We have already identified. Divided by hypotenuse is again PR. Now use their values, 5 by 13. This is our cos P. And finally tan P. To present beauty will give you the definition. Perpendicular by base. Perpendicular is QR. Divided by base is PQ. Use their values. It will be 12 by 5 therefore. That completes the solution of this question. We found sine P, cos P as well as tan P. Now the last question of this exercise. Question number 11. You are given some statements. You have to state whether those statements are true or false, and then you have to justify also. Before we begin analyzing these, one thing you have to keep in mind. Let us consider the triangle ABC, right angle at B. We have already seen, discussed that there are two acute angles. You have to choose first one of the acute angles. For example, angle C is the acute angle chosen. We may choose angle A also. Now, with respect to the acute angle that you choose, you can decide base and perpendicular. Hypotenuse does not depend on it. That is the side opposite to right angle, and you can identify here it is AC. With respect to acute angle C, BC will be the base. Use the procedure we have already discussed to identify. AB is the perpendicular. Now, if you look at this figure, one of the results you have read in class 9, we have proved hypotenuse is the longest side of the right triangle. Out of the three sides, hypotenuse is the longest side. We have read side opposite to the longer angle, larger angle is longer. Here angle B is the largest angle. So the side opposite to this will be largest. AC is the largest. We have proved this question in class 9. In a right triangle, hypotenuse is the longest side. Now, out of the two remaining sides, base and perpendicular, Presently we have chosen angle C as the base, angle C as the acute angle. We got BC as base, AB as perpendicular. And if you look at this, you can easily find that AB is larger than BC. Means perpendicular, AB is perpendicular presently, is larger than base. BC is the base. But will it be always so that perpendicular in the right triangle is larger than the base? Hypotenuse is the largest one. Forget about that hypotenuse for the time being. Consider these two sides. Will perpendicular be always larger than base? It is not. The result is, answer is no. Because we will not have always the acute angle that is chosen, the larger one. Right now, I have chosen angle C. We can see out of the two acute angles, angle C and angle A, angle C is larger than angle A. But it is not necessary that you'll always choose this larger acute angle out of the two acute angles. We can choose any acute angle as per the instructions. Therefore, sometimes you may choose angle A as the acute angle. Then what will happen? Will this AB continue to be perpendicular? Will BC continue to be the base? No, now these will change, because now this AB is the adjacent side of angle A. The perpendicular therefore will become now base. And correspondingly base will become perpendicular. So what will happen then? Base will become larger than perpendicular. Now AB will be base, BC will be perpendicular. In the figure we can easily see AB is larger than BC. So base will be perpendicular. So this is not always possible that perpendicular of the right triangle is larger than base. We may sometimes have base larger than perpendicular. And even the two may be equal also. Base is equal to perpendicular. This also is possible. And you can easily think about the situation when these will be equal. You can use the result you have read in class 9, proved in class 9. Equal sides of a triangle have equal angles opposite to them, or the converse of that. Equal angles of a triangle have equal sides opposite to that. Now it is not necessary that in the right triangle the two acute angles will always be unequal. Those can be equal also. The diagram that we have presently on the board has two equal acute angles. Those are unequal. But we may have a situation where the two acute angles will be equal. Each will be 45 degrees. This will be 45. This also will be 45. Equal. Then what will happen? Then base will not be larger than perpendicular, or perpendicular will not be larger than base. But the third situation will arise. Base and perpendicular will be equal. That is the case when the two angles are equal. Now keeping in mind all these facts, you have to now answer the questions of 11th question. First part here we have the value of tan A is always less than 1. We are asked that the value of tan A always less than 1. The value of tan A is always less than 1. This is the statement. You have to answer this, whether this is true or false, and then you have to justify this. To answer this, you have to keep in mind these facts. You have to use the definition of tan. Well, the definition of tan says tan is perpendicular by base. It is a ratio, perpendicular and base, ratio of perpendicular and base. Now we have three possibilities about this ratio. Just now we have discussed. We may have perpendicular larger than base. This is one option. We may have perpendicular smaller than the base. This is the second option. We can even have perpendicular and base of equal length. Perpendicular equal to base. This is the third option. Now applying these here. If perpendicular is larger than base, in case of first option, when perpendicular is larger than base, means numerator is larger than the denominator. Now, will the result be equal to 1, greater than 1, or lesser than 1? We'll take an example. We suppose have this perpendicular by base equal to 5 by 4. Perpendicular is larger than base. 5 is larger than 4. Now find out the value of 5 by 4. You will get 1.25. As we divide 5 by 4, we get 1.25. And what do you say? 1.25 is larger than 1. Therefore, tan of A, which is perpendicular by base, in this first option becomes greater than 1. Question says, is tan of A always less than 1? Now you can answer, it is sometimes greater than 1 also. In the second option, this option, when perpendicular is lesser than base. Now perpendicular by base then will become, take an example again, choose two numbers such that perpendicular is smaller than the base. Let it be 4 by 5. Perpendicular, I have now taken a smaller number because perpendicular is smaller than base. Base has larger number. And when you divide these two, you'll get 0.8, which is lesser than 1. So here it is lesser than 1, when perpendicular is lesser than base. And in the third case, when the two will be equal, perpendicular and base will be equal, you may choose the example 5 by 5, 4 by 4, and the result will be equal to 1 in that case. Tan A therefore has all the three possibilities. It can be greater than 1, it can be lesser than 1, it can be equal to 1, but the statement says that tan A is always less than 1. What do you therefore find? It is true or false? Well, it is false. Tan A is not always less than 1. It can be greater than 1 also, it can be lesser than 1 also. So that is the justification of this first part. Now considering second part. Second part is, we have to answer, it is given that sec of A is equal to 12 by 5. Sec of A is 12 by 5. For some value of angle A. Some value of angle A. We have to find out whether this is possible or not. Is it true or false? Can sec A be 12 by 5? Now by definition we know sec is hypotenuse by base. Sec is the reciprocal of cos. Cos is base by hypotenuse. Curly black here. Base by hypotenuse. So sec is therefore hypotenuse by base. And we find hypotenuse is the largest side of the triangle. And here we have to compare that hypotenuse with the base. Only two numbers. So we can say hypotenuse is therefore larger than base. This becomes therefore larger number divided by smaller number. In sec, we therefore always have larger number in the numerator, smaller number in the denominator, and that is what is given to us. 12 is larger than 5. Larger number is in the numerator, 5 is in the denominator, the smaller number. Therefore, this statement is true. Coming to the explanation of part number 3. In the third part, we have cos of A. As per the statement, is the abbreviation used for cosecant. Cosecant. Cosecant of acute angle A. This is given to us. As per the statement, we have to say whether this is true or false. Now we have read in the definition about cos. Cos is an abbreviation. It is an abbreviation of cosine of acute angle A. But the statement said it is the abbreviation of cosecant of angle, acute angle A. Therefore, it contradicts the definition. Therefore, this is false. Fourth part is again a similar one. We have cot A here now. As per the statement, it is product of cot and A. Product of cot and A. Now we have already read in the definitions. What does cot A represent? It is an abbreviation like this. Cos A is an abbreviation. Likewise, cot A also is an abbreviation. It is abbreviation of cotangent of acute angle A. It is not the product. It is not the product of C, O, T and A, or it is not the product of cot and A as stated in the statement. Therefore, this is false. Last part, part number 5, is similar to the part number 6. This time, instead of sec, sine trigonometric ratio is given. Sine of acute angle theta is 4 by 3. Now, whether this is true or false, the justification of that will be similar. What we did here, we first found what is the definition of sec. And then is it the ratio of larger number and smaller number, or smaller number and larger number, or the two numbers are equal? We found it is larger number by smaller number. Compared it with the given result, we found it was true. Now coming to sine, sine we know is perpendicular by hypotenuse, by definition. Therefore, what will you say? It is the ratio of larger number and perpendicular, larger number by smaller number, or smaller number by larger number. We know hypotenuse is the longest side. Perpendicular is therefore smaller than hypotenuse. Hypotenuse is larger number. So it becomes smaller number divided by larger number. But in the question, the ratio given is in the form of larger number by smaller number, which means this result is false. With that, this exercise is over. We'll conclude this day.